to you during this module. So that's my name, and you have my email address there, only for use in cases where you want to discuss some personal issue that's affecting your performance in the course. Questions regarding course material that are sent to my email address will not be answered. Okay. I'm going to set up a forum on Moodle where questions to do with course material will be answered. Why am I doing that? Well, I have 600 students at NCI, another 50 or so in DBS and yourselves. I can't possibly keep up with all. But also, if I answer a question on the Moodle forum, everybody else can see the response. And they may well have had the same question, but didn't think to ask it. So everybody benefits. All right? Okay, anything else on here? I don't know whether you're Group A or Group B. Do you have access? Can somebody show me the Moodle page you have? Because I've only got access to one Moodle page. And there are only two participants on it, me and somebody else. Let's see what you've got. So for this advanced databases module, and for some reason, the Mac won't work with both screens. So it's going to be everything up here for the moment until I buy an active splitter to use in the place of the one they have here. So my apologies for that. So an overview. Somebody has written onto this screen with a permanent marker.
There is March.
An expensive piece of kit. Okay, so this is an overview of the module. Today we're just going to be going through a sort of revision. I'm sure you all remember what you did on your databases module, yeah? Every little detail?
I don't think so at all.
No. So in order to get you back up to speed again, I'm going to be going through a sort of a whistle-stop revision of the material you did. This is all on Moodle, so you don't need to take... I'll make sure you get access to the Moodle page. So today, we're going to look at SQL, DDL, and DML. Can anybody tell me what they are? Data. And the other one? Data manipulation and definition. Okay. We're going to look a little bit at constraints and referential integrity. We're going to look again at the first to third normal forms. Have you done the first three normal forms? Okay. After I've gone through the intro, I'm going to get you to introduce yourselves, okay? So I get to know a little bit about you. You have to forgive me if I don't remember your names next week. It's not that I'm not trying. So next week, we're going to look at procedural SQL. Without the procedural SQL, what sort of languages say SQL DDL and SQL DML? Do you know about the different language types? Anybody? Imperative, declarative, functional? You have done those yet? Okay, let me give you a quick summary of it. An imperative language is where you tell the computer how to do something, like programming in Python, or C, or C++, or Java, or any of those, is imperative programming. Declarative language is where you tell the computer what you want, but not how to achieve it, how to obtain the information you want. Examples of that are a language called Prolog, which is only used really in the artificial intelligence community, and SQL. Okay, but next week we're going to move into a sort of SQL imperative programming where we write procedures and triggers, store procedures and triggers. Oh, sorry, store procedures and functions. Then on the 1st of October, we're going to look at a way of getting a handle to the result of a query and iterating through it on a database cursor. We're going to look at triggers, which are special types of functions that operate when a change is made to data in a database table. And then on the 8th of October, we're going to look at exception handling. So what happens when something goes wrong? You specify how the code should recover. And then on the 15th of October, we're going to look at optimization. And we're going to look at optimization from the perspective of the database software. There are two ways we can optimize. We can optimize by buying really expensive hardware, and we can do optimization within the database. So we're going to look at indexes, materialized views, and looking at analyzing queries using the explain keyword. So, 17th, that's wrong. I'll have to change that. Seem to have ended up with 2. There we go. Have I ended up with 2 pages exactly the same? I have. Apologies. So on the 5th of November, we're going to be revisiting the EOR model. I think we're missing something in there. 15th, do we have a class after the 15th?
It's a bank holiday, I think, at the end.
There is a reading week. So then we got revisiting the EOR model. We're going to be looking at something called the extended EOR model. Generalization. So this basically introduces sort of kind of object-oriented perspectives into the EOR model. So you've got subclasses, superclasses, and inheritance, just as you would do. Have you done any programming modules?
Yeah.
What kind? Java. So you'll be familiar with the concept of superclasses and subclasses. So we're going to look then at mapping that extended EOR model onto a database schema. We're going to look at the 4th and 5th normal forms. You think the first 3 were bad enough? And we're also going to look at another one which I haven't put on there. It's called the Boyce-Codd normal form, BCNF. And we're going to look briefly at SQL standards and how they've evolved over the years. 19th of November, we will look at the object relational model, and we will look at native object databases. Now, we may not get any hands-on on this, but for those of you who are interested, there's a database called Postgres, which kind of lies between regular RDBMS and object. Then we're going to go away completely from RDBMS. We're going to look at XML. I'm sure those of you who've done Java are very familiar with it. Yeah? We're going to look at XML native databases and the use of XPath and XQuery. 3rd of December, we're going to look at complex data in the extended EOR diagrams, binary data storage and retrieval from relational databases. And then finally, on the 10th of December, we're going to look at big data and NoSQL. Now that's going to be very much an overview. On the evenings I teach an entire class in DBS on big data, so you're not going to become proficient, but you'll get some idea of what it's about. Why these are all doubling up on me. So, oh yeah, assessments. So your assessments are going to be 20% more or less theoretical in continuous assessments. 30% in-class practical and 50% exam. Let's say we look at triggers or stored procedures. I give you a little exercise to do on one of the standard databases. It's mentioned on the Moodle page, but then again you don't have access to the Moodle page. So unfortunately, we can't go there right now. But there will be a short practical to accompany and on the same day that we do the particular topic, so it should be fresh in your mind. And that will be divided up. I forget how many of them over the duration of the module. I really can't remember, but I will tell you later on. So they'll be short and maybe worse, 10% each or something like that. Okay, any questions so far? Can you down at the back, all of you down there, can you see this? I can't. I can't. No, unfortunately. Might try to see if we can get the room changed, or I'll get myself. See, the HDMI output is split between here and here, and my computer won't work with the splitter. Right, we'll start here and work our way down and back up and down again. If you could let me know who you are and what experience you have prior to. What time do you finish on this class? So it's doubling up on everything here. I don't know why. Let me just try. See if that works. That's more like it. So we're going to look at a refresher of SQL data definition language. Like, it isn't, it's part of SQL, it's not separate from it. But SQL has three major parts: data definition, data manipulation, and then the procedural add-on. So you will remember how to create a table. By the way, I use the word table and relation interchangeably. A relation is a table. It's not the relationship between tables. So just to make sure you understand that when I say relation without the ship after it, I mean a table. That's official theoretical terminology. So creating a table, you give it a name, you have the parentheses, and then you have a list of attributes with data types. I'm sure you all remember the data types: int, var, varchar, date, datetime, and so on. So I've given an example here: create table course ID int 11, not null. Course name varchar 45, default null. So what does the default mean? Well, you can add a default constraint to an attribute saying, well, this is going to be its default value if one is not provided. Course code car5 defaults to null. And then we have a primary key of course ID. So that's a basic create table example. And apologies again down the back, I didn't realize you weren't going to be able to see all this. So what happens when you have a table that you want to change? Do you drop it and recreate it completely? Probably not a great idea. So the alter table statement takes one of three forms. Depends on what you want to do. Alter table, table name or relation name, which I will use these two interchangeably. Add attribute name, data type. What does that do? It adds a column with a particular data type to the table. That's how you add a column. The second type is alter table, table name, drop attribute name. What does that do? Deletes a column. Add all its data. And if you do it by mistake, you better have a backup, because there's no way of getting it back. Third one, alter table, table name, modify column, and you give the attribute name or the column name, and then the data type. So it allows you to take an existing column and change its data type, provided that the data within the column can be changed. It may fail if the data can't be changed. So let's say if you have a column with a data type, and you try and change it to an int, probably not going to work. But if you have a column with, say, a character 1 type, which only contains numbers, you will probably be able to modify it so it becomes an int. It really depends on the data in there. There's three examples basically: alter table, course, add column, active, tiny int. What is tiny int? Does MySQL have a Boolean tag? Anybody? It doesn't actually, yeah. The only thing you can use is tiny int. And it's basically set to null after course code. So in MySQL we can say where it appears in the list of columns. You can say put it in after another column name. The second one here is an example of the drop. Alter table course, drop column active. That's it, it's gone. Everything that was in there is gone. And here's the last one where you're modifying a table. So I've created the table as a tiny int and I've modified it to become character 1. Alter table course, modify column active, character 1, not null. So I've also added a not null constraint. Am I talking a different language here, or does everybody understand what I'm saying? So far, so good. Right. Anybody not? Anybody going, what's he talking about?
One in parentheses, does it mean just one character?
So you could have 5 in parentheses, in which case you would have 5 characters. Okay, quick question. What's the difference between varchar and char?
Char is in the characters, and varchar you have to just put the initials, numbers and characters both there.
Varchar will store in memory the exact amount of characters you put there. And
Tell everybody else about. Make sure everybody else hears you.
yeah, Varchar is just gonna store in memory as many characters as you put there. You just say that the maximum it can contain.
So
You're not gonna-
you're right. So varchar will store only the length of whatever's put into it, not the actual specified length. That's just the maximum. Char, on the other hand, will occupy the entire space, even if, say, if I had char 128 and I put a string of 5 characters in there, it's going to take up 128. So for optimization of space, you try to go with varchar, unless you know. Like, for instance, in this country we have a social security system and a PPS number. PPS number is 7 characters. It's always going to be 7 characters. Or it's always going to be 7 or 8 characters. Some cases have an additional letter, so we can make it 8. Everybody's going to have at least 7 and some are going to have 8. And we're not wasting that much space, so we could make that char. What have I done here? Yeah, table deletion. Drop table statement will delete an entire table, contents and definition. So the entire thing will be gone. So the following example will delete the data in the course table and remove the table completely. Drop table course. What if we don't want to do that? What if we just want to empty the table? Well, then we have a truncate table course that will just empty the table and we'll leave the structure intact. Okay, still with me? Good. Okay, we're going to look at constraints. So the primary key constraint is used to specify the attribute or attributes that are going to be used to uniquely identify a row. A row is also called in official database relational theory, it's also called a tuple. Have you heard that term before? Yeah. Okay. So when I use tuple and row, I'm using them interchangeably. As such, values in primary keys must be unique. So if you have two attributes in a primary key, every combination in there should be unique. And there should be no nulls. Nulls are not acceptable in a primary key. So each table can have only one primary key and may be composed of one or more attributes. Okay, it all has to have one, but may require more than one. So sometimes if you have a junction table, do you know what a junction table is? And when you're trying to create a many-to-many relationship, you have to have a table in between. Well, in that case, both the attributes in the junction table will need to form the primary key. Multi-attribute primary keys are also known as compound primary keys. And this shows an example with a single attribute, creating a table student. I'm going to skip over the creation of the attributes. At the bottom we have constraint pk student, which is the name of the primary key constraint, primary key, brackets, and then the name of the attribute that we're going to use for it, student ID. Okay, is everybody with me? And you can also add, let's say, what happens if you go to create a table and you're a little bit tired, it's just coming up to time to go home and you forget to put a primary key on the table. Do you have to redefine the table completely? No. You can use the alter table statement to add a constraint. And in this case here, the example is alter table student, add constraint, the name of the constraint. The keyword's primary key, and then brackets student ID. So you can actually come along after creating the table and add your primary constraint. And then finally, you can also remove the primary key by going alter table student in this case, drop primary key. Or you could also do drop constraint and the name of the constraint. Okay, foreign keys. When do you use foreign keys? Anybody? Why do we need foreign keys?
The keyword of another table using. It's the keyword of another table.
Yeah. It's when we're relating two tables, and we're relating the two tables on a common attribute. So a foreign key is used to relate two tables together and is an attribute or more than one attribute in a table, the child table, that refers to the primary key of another table called the parent table. Right. Foreign key can be added as part of the create table statement, and I'm sure you're going, yes, it can also be added as part of using an alter table statement. So I'm going to skip through all of the creation of the attributes and our primary key constraint, and I'm going to concentrate on the bit at the bottom here. Sorry. Constraint. I'm giving the constraint a name. So in this case, I'm calling it FK title. Have you been taught about foreign key constraints before? Yeah. Right. How are you generally taught how to name them? My general technique is to use the name of the foreign table plus its attribute name that we're linking to. So in reality, this should be FK title ID or something like that. I just did this to make it short. Were you given any advice on how to name foreign keys? No?
Yes. You're using the same name as the
Well, generally, as I said, I would go FK foreign table name, FK underscore foreign table name underscore foreign table attribute. Right?
Not sure, but someone told us
Sorry?
not to use underscore underscore.
Sorry?
Someone told us not to use underscores.
You can use underscores.
Yeah, you can.
You can go with one or the other two styles. One style is to use the underscores. The other one is to use camel case. My advice to you is pick a style and stick with it. And the same when it comes to naming conventions. Before you start designing a database, decide what your naming conventions are going to be and stick to them. And that way somebody's coming along to work on your database later will not find themselves with multiple different methods used. Okay. As I said, it can be added with the alter table statement as well. So we're going alter table student, add constraint FK title. And then underneath foreign key with the name of the foreign attribute. Oh, sorry, with the name of the local attribute, sorry. And then references the name of the foreign table and the name of the foreign attribute. So references title, parentheses, title ID. And it can also be, alter table can also be used to drop a foreign key. Using the alter table statement, drop foreign key and the name of the foreign key. Have you done check constraints? No? See, this is why I'm doing this today, and you say you can't remember. I bet you probably have. Okay, well, okay, if you haven't, no big worry. You learn about it today, if you haven't learned about it before. Okay. When you're specifying a data type, for an attribute, you're already constraining the types of data it can store. But let's say an int column can only store integers. But well, let's say we have an age column and we want to make sure that age column only stores values 18 or over. Right, here's the example. Now I generally put the word CHK before check constraints in their name. So I've got create table student, all the attributes here that I'm creating, and then constraint. CHK student age. Check age greater than or equal to 18. So what it's doing is it's before the data are saved, it will go through every check constraint and make sure that each of the conditions is met. Otherwise the data cannot be saved. You try and save the value 16 into age there, what will it do? It will throw up a constraint violation. So it's a way of further restricting the acceptable values of data within any particular column. Right. So has everybody got what a check constraint is? It is a condition that must be met for a particular column before the data can be saved. A unique constraint. Have you done unique constraints? Yes? Definitely? Maybe?
Yes.
Okay. So what is the unique constraint doing? Sorry. Yeah. It makes sure that no duplicates exist within that column. Do we need a unique constraint on the primary key?
Most.
It's implied. If something is a primary key, it must be unique. Well, you get the idea anyway. So any column that must contain unique data, you use the unique constraint specifier. So for instance, I have my student table with an attribute PPS number. I put in var car 7, I could have put in car 7 or car 8. I've forgotten what the length is. It's either 7 or 8. And I have a constraint, UK, which I tend to use for unique keys, unique values. PPS number, unique, parentheses, PPS number. So what's that doing? It's saying the field PPS number, or the column PPS number, must contain unique values. Can two people have the same PPS number?
No.
Well, unless somebody's been copying PPS number cards illegally, then no.
Yeah.
So you can be sure that's unique. And you can also, going back to the previous check constraint, say for instance, sometimes national ID numbers have particular formats. Now I don't know about the ID numbers where you all come from, but I do know the one in Italy, the Codice Fiscale, is dependent on your date of birth and your place of birth and things like that. So you could have a very fancy check constraint to look at the person's name. I think it's the first 3 letters of the surname come in there as well. Their place of birth and date of birth, and make sure that the Codice Fiscale matches the other details they've given. So your check constraints can be quite complex. I don't know about what is the national ID number? Do you have a national ID number where you come from?
Just numbers.
They're just numbers. Okay. So it's like here. In Italy, you know, Italy being a bureaucratic country, they have to make things nice and complex. But it does make validating them very easy. Okay. I'm feeling we might finish up a wee bit early today. That was not my plan, but we'll get through what we have to get through today. And anybody has any questions about what we're going to be covering over the next few weeks? And I have to make sure that I have everything working for this. Can't do this again. Right, did you cover views? Okay, somebody tell me what's the point of having a view?